we talked about ozone. The kind of the W questions, what, when, where, why. Well, we didn't say when. I should have asked that question. But anyway, the what, where, why about ozone. And we ended up recognizing the fact that in order to truly understand why ozone is a problem in one place and a benefit in another place, we have to remember what we know about atoms and look a little deeper into how bonds are formed and what that tells us about the chemical and physical properties of that particular molecule. So first, I want you to think back about what you already know about atoms, and that is that they are made of there's lots and lots of subnuclear particles that the physicists have talked about, but we as chemists only need to care about 3 subatomic particles. That is protons, neutrons, and electrons. And you remember that protons, protons and neutrons, of course, are in the nucleus, and that the protons, that's the atomic number. That's how we define different elements, atoms of different elements, by the atomic number. And remember, the sum of the protons and the neutrons is what gave you the mass number. Okay, we learned that in Unit 1. And we also recognize that electrons are found, outside the nucleus, in the sphere of the atom. And we said we'd come back to the details of the electrons later, and I guess now's that time. Now, when we say outside the electrons, or excuse me, outside the nucleus, what do we mean? Well, if you take something as simple as a hydrogen atom, remember hydrogen? Hydrogen just has 1 proton and 1 electron. Well, we know the proton is going to be in the nucleus, so I'll just draw that and say, okay, the proton is in there, that's the nucleus. And the electron is somewhere outside the nucleus. Sometimes when people are drawing a model of an atom, they'll just put the nucleus, a little dot in the middle, and then they'll put the electron outside, and then they'll put sort of a circle around it to indicate that the electron is somewhere moving around in some place outside the nucleus. And we call this the orbital model, but that's really a very immature model of the atom. It's better to think of the atom like this, that there's the nucleus and there's the proton. In this case, there's only 1 proton in the nucleus. And then the electron is found somewhere. Now, there's only 1 electron, but it's found somewhere in this cloud outside the nucleus. And so we model it this way with all these little kind of, dots around. And sometimes the dots are a little bit more densely arranged closer to the nucleus, depending on, what you're talking about. But in this case, what this means is the electron is somewhere in this cloud around the nucleus. We can't say exactly where. We can just say it's probably in some radius of some sphere around the nucleus. Okay, so this is a better model. This doesn't mean that there's a whole bunch of electrons around this proton. This means that somewhere in this shaded area, you're going to find the electron. All right, and where it's found, somewhere in this shaded area, we call that a level. So it's not a level like an orbit where it's fixed, at a certain distance, but the level nevertheless means it's some energy level out from the nucleus. And then the more electrons you have, the more levels you may have for them to be found. But since there's only 1 electron here, we'd say, oh, it's just, it's in level 1, that sort of a thing. Okay, so that's what we know about atoms, that the electrons are somewhere outside. And as it turns out that, in modern day, we can correlate the electrons and the level that the electrons are in with the periodic table. And you know that the periodic table is arranged in order of increasing atomic number. And you know that in a neutral atom that the atomic number is the number of protons. And since it's neutral, the number of protons is going to equal the number of electrons. So we can figure out how many electrons are in an atom based on the atomic number, which is found on the periodic table. Okay, and so as you add electrons, as you move across the periodic table and the atomic number increases by 1, as you move across the periodic table, the number of electrons also increases by 1. All right, and so what we can see now is there's trends periodic trends of the periodic table of the of the elements on the periodic table, and we can explain them by this modern view of the electrons being in certain levels.